Today, our speaker is Louis McCurley. Louis is the author of Falls from Height, A Guide to Rescue Planning, and Rope Access, Working Safely at Height, is committed to making principles of safety in work at height achievable in every workplace. As a certified rope access technician and technical rescue specialist, Louis has faced unique fall protection challenges, unique environments, including general industry, towers, turbines, agriculture, entertainment, and more. Past president of the Society of Professional Rope Access Technicians, Louis works with standard settings in organizations including ANSI Z359, NFPA, ASTM, ISO, FEMA, Carthage Institute, and others. Louis is CEO of Pigeon Mountain Industries and Vertical Rescue Solutions. Please join with me in welcoming our speaker, Louis McCurley.
Thank you, Sandra. How many of you guys believe in 100% fall protection? Big believers in 100% fall protection? How many of you guys believe that if you have a work at height plan that you also have to have some sort of a rescue plan? Cool. So you guys are actually real work at height people. I'm glad to see that. We're going to talk a little bit today about rope access, and we're going to talk about fall protection specifically in light of rope access. I come from a company called Pigeon Mountain Industries. I do not own the company. I'm just CEO of the company. But we manufacture life safety rope and equipment for work at height, primarily for rescue, professional rescue, also for rope access and other types of work at height. PMI has a training arm called Vertical Rescue Solutions, and then we also work with a little organization called SPRAT, the Society of Professional Rope Access Technicians. Who's heard of SPRAT? I always ask that question because it makes my heart feel good. I helped found that organization back in the mid-1990s because here in the United States, there was a general misunderstanding of work at height. There was a general misunderstanding of people who were hanging on ropes doing work. People perceive people who are hanging on ropes doing work as essentially being climbers or climbing or using recreational techniques, and that just ain't true. And we're going to talk a little bit more about that today. And as we talk through this stuff, if you guys have any questions, feel free to just raise your hand at the time because it's a lot easier to answer the question while we're talking about it than it is to hold questions at the end, in my opinion. And in addition, if you have a question that I'm not answering or in the process of answering, it's probably more important than what I was talking about anyway. So I'm going to use my handy-dandy little clicker here, which is my right forefinger. Falls kill a lot of people. They kill a lot of people every year, and I know I'm preaching to the choir, and I'm not even going to spend a whole lot of time on this slide because you guys know that falls year after year continue to be, they cost us huge amounts of money, they cost us attitude in the workplace, they cost us productivity in the workplace, and they cost us just a joy of work that people don't necessarily enjoy coming to work when they have to fear for their lives. I'm a firm believer that everybody wants to go home at the end of the day. They just do. And I'm not a believer in the fact that people are just going to do stupid stuff. I think if you train people properly and equip people properly, we can solve the problem because they want to live even more than you want them to live sometimes. I didn't mean that like it sounded. So, fatal occupational injuries by major event 2013. So this is a couple of years old. As you know, data, we're always chasing data or dragging data behind us because it's always old by the time we get to see it. But really what I want you to notice in this slide is this one here. So falls to lower level are the kinds of falls that I'm most concerned about. I want those falls to lower level to stop. Other types of falls, if I trip over the cord in here, there's not a lot I can do about that from the kinds of methods that I'm going to talk about today. But those falls to a lower level are really what I want to address. And my question is, my founding question of this whole thing is, why do falls year after year after year after year after year continue to dominate workplace statistics? It makes no sense. It's been the same for as long as I can remember. I've been working in this industry for quite a long time. I've actually been in this industry for 30 years. And you know what? It's still in the top 3 every year. And in fact, many years, it's in the top 1. And that's just something that I think we need to fix. In fact, we're going the wrong direction. If you look at this slide, this is from the U.S. Bureau of Labor Statistics, and it shows that falls, according to 2012 to 2013, are actually on the rise. That's a bad thing. Why are falls on the rise? Well, I can tell you that it's not due to a lack of regulation. We got lots of regulations out there, starting with this one. The law of gravity always applies. So that's the first rule that trips us up, no pun intended. But there's lots of other rules that have to do with fall protection as well. Anybody familiar with this one? All right, I hope all of you are familiar with this one. And this one, and this one, and this one. In fact, there's so many rules sometimes that it kind of gets difficult to know which one to follow when. And they kind of get tangled up in themselves sometimes. And many times they're exclusions, which is another subject that I won't get on my soapbox about today, or we'll be here all day. In addition to the regulations, there's standards. So we have to meet the regulations, but we also have to meet the standards. Well, standards, and you guys all know this, but I'm just going to repeat, standards are not regulation. Regulation has the effect of law. It defines the government requirements within a given jurisdiction. Standards, theoretically, are intended to help us achieve or meet those regulations. So the idea behind standards, general consensus standards, is to provide specifications or guidelines to help us meet the letter of the law. Industry standards are a little bit more localized. They usually have to do with one particular kind of an industry or another. But again, they're very focused on techniques or methods or processes. They're not quite that high level that regulation often is. So, are there general consensus standards in fall protection? What's your favorite one? That's right, the one that everybody loves to hate, Z359. There's also ANSI A10. Right? We've had that one over the years. And again, sometimes it's a little difficult to know what to follow when and what to know or what your requirements are at any given moment. But the role of standards, again, just to repeat, is to help us comply. Yes, sir?
In those set of standards, what's your take on the proposed regulation for fall protection? Is it used, not used, or what does the industry do?
On the new proposed document, it's hard to say, because the last one that I saw that was a real draft was in 2010, and they keep saying no, you can't use it yet, and it's theoretically. And are there any OSHA guys in here that can give us an update? The last update I saw says it comes out in August, so they keep changing it. But I saw one just the other day that said that the subpart D was delayed till August this year. I'll believe it when I see it. They've been saying that but anyway, but we can't use it. You can't use it today because it's not really, it doesn't really exist. But the standards are theoretically trying to help us meet those regulations. And they're providing some additional detail and clarification. So that's kind of the role of standards. The problem is, people are still falling. And my favorite study is this one, and it's kind of old now. This is a study that was done by two gentlemen in the construction industry, and they looked at about 3,000 falls in the construction industry over a period of 10-ish years. And what they found in their study was that about 30% of the falls were attributable to inadequate, inappropriate, or complete lack of PPE. Well, I thought that number was kind of low, but that's kind of interesting, because I think I see a lot more people than that out there without PPE. But I thought that was an interesting number. But this was the most interesting thing that I found. It noted that there was no significant improvement after the 1996 revision of the PPE standards. So you're asking about subpart D in the new document that's going to come out sometime soon. Is it going to have an effect? I don't know. But the last time we went through this exercise, it didn't. And I think the reason is because you can't legislate people into safety. You've got to teach people and give people the techniques and the systems and the equipment and the knowledge that they need, because they want to keep themselves safe. So the reasons that they cited in their study that equipment was not being used or was not being used properly was that the equipment was infeasible to use or infeasible to use properly. People said that they used the equipment wrong. So they connected to something they shouldn't have connected to, or connected in a manner that they shouldn't have connected. Or people were left suspended and could not be rescued in a timely fashion, and that actually has contributed to a couple of deaths. So you look at conventional fall protection methods, and this, I think, is the gist of the problem. And I sit on ANSI Z359, and one of my opinions regarding that effort is that We're trying to make people safe by making the systems so incredibly simple that anybody can do it. We're trying to standardize the equipment. If the equipment looks exactly like this, and the guy who's wearing it takes exactly these actions, then everybody's going to be safe. The problem is that there's a whole bunch of work sites out there that aren't conducive to these perfect scenarios. These great little pictures that we sit around the table and talk about at ANSI. They're great ideas and they're great concepts, but the reality is they don't fit into 100% of the work sites. They just don't. So that's where rope access comes in. Rope access is not nearly as dependent on things being a certain way as are other certain types of fall protection methods. Unfortunately, on many of the work sites that we're at, walkways and platforms, they're just not where you need them. If there are stairways or ladders at all, they're probably in the wrong place. And of course, the old question of, is that a 5,000-pound anchorage? An engineer probably hasn't even looked at it, much less, because he didn't plan on using it for an anchorage, did he? And so those are the realities of many of the work sites that I'm talking about today. Now, if you're in a situation where typical, conventional fall protection works for you, keep doing what you're doing. Because that plug-and-play philosophy, that same way every time, that clip it and go, great. If that works for your environment, that is the simplest way to do it. But if your environment is not conducive of to that, don't try to make your guys actually conform that equipment into an environment or a circumstance that it doesn't fit. That's called misuse of equipment, and it doesn't work very well. So rope access is not climbing, it's not rescue, it's rope access. Rope access is a very specific system of work at height that utilizes every time, at least two life safety ropes. One as a primary and the second as a backup. It allows incredible versatility because of the techniques and the equipment used, and I'm going to show you some of that in a moment. And the guys have prompt rescue capability. I can rescue you, you can rescue me. As a two-man team, if I can get myself into a pickle, I can get myself out of it. And if I'm incapacitated, you as my partner can get me out of it. And the way that we know that is because we test the guys on it, and they can't get tested, they can't get certified without proving that. That's incredibly important. So there are standards that apply to rope access, but there aren't many in the United States. The primary standard that we use that applies to rope access is an ISO standard. It's an international standard, and it's 22486. And I'm sorry, but I noticed as I was looking over this just before I came in here that I think it's 22846. So if that's the case, I apologize. But if you don't find it under 22486, it's 22846. I'm really sorry. I think I was dyslexic on that one. But anyway, the bottom line is that the ISO standard establishes worldwide guidelines that are accepted by countries all over the world for rope access practices. And the practices and the things that we're going to go through today all come from that standard. There are also some standards in the United States. ASTM E2505 is actually in ASTM's Buildings Committee. It's a part of their Building Maintenance Committee. And that standard is much smaller than the ISO standard. It basically sets some high-level guidelines, but it doesn't tell you much about how to achieve them. But at least it acknowledges kind of the high points, the key points of what's important in rope access. Z359 does also address rope access in a very brief kind of way. In ANSI Z359.2, there is 5 paragraphs that talk about, just basically establish the fact that rope access is different from other forms of fall protection and therefore has different requirements. The equipment is different, the systems are different, the work methods are different, and the guys need extra training. There are some industry-specific standards, such as those written by the Society of Professional Rope Access Technicians. These standards are actually downloadable from the web. The SPRAT Safe Practices for Rope Access Work document is a document that outlines the employer responsibilities as well as the employee responsibilities when it comes to having a safe rope access program. And the certification requirements are what you as an individual, or your guys as individuals, are tested to become rope access technicians. It tells you exactly the skills that they have to have and kind of how to do them. And it's all downloadable for free at sprat.org. So the Society of Professional Rope Access Technicians was established in the mid-1990s, and the purpose of the organization was really to create some consistency in safe practices. Let's make sure that every time we're doing rope access, we're doing it kind of with the same philosophies, kind of with the same principles. You're not using climbing techniques one day and caving techniques another day. You're not using recreational techniques at all, but you're doing a system that was designed for industrial applications. We also want to inform and educate safety professionals, and in fact, if your organization is more interested or is interested in more information about rope access, SPRAT will help you come up with that. The most important thing that SPRAT does is certification of technicians. So when I teach a 4-day rope access class, and classes are usually either 5 days or 6 days, 4 days of training and the 5th day of testing, or 5 days of training and the 6th day of testing. When I do a 4-day rope access class, which is what I do through Vertical Rescue Solutions, or my guys do, we teach for 5 days, and then a representative from the Society of Professional Rope Access Technicians comes in for the final day to do that test. And he executes a written test, a verbal test, as well as a skills test. And he puts the guys through their paces. And so at the end of the day, they've had essentially a driving test. And they know that at least on that day, they knew those skills, and they are certified for a 2-year period. There are other certification organizations worldwide, all over the world. ARAA in Australia, IRATA in the UK, SARA in South Africa, FISAT, SRAA. But the bottom line is everybody follows the ISO standard as a baseline. Everybody follows that. So when in doubt, look into the ISO standard as your baseline. Z359.0, which is the definition standard from ANSI, defines rope access in this way. It says, rope access is a technique using safety ropes, normally incorporating 2 separately secured systems. One is a means of access, and the other is a secondary system used with a harness in combination with other devices for access to and from, as well as suspension at, a place of work. Sounds pretty generic, but when you get down to the details, it's actually pretty specific. So you've got trained certified workers. This guy is actually a level 3 rope access technician. He's been working on rope for probably 10 or 12 years. He's using equipment that was designed for rope access. He's not cross-utilizing recreational equipment. He's not cross-utilizing fall arrest equipment. He's not using rescue equipment. He's using a backup device that is specifically designed for rope access. He's using a primary descender that is not a recreational descender. It was specifically designed for rope access. It's all purpose-designed equipment. And he's working in a management system wherein a level 3 is supervising all work. So, and there is a management system as well that follows this. Where does it fit in the hierarchy of control? Well, this whole thing, even Z359, we can't even agree on these blocks in Z359. So, but this is kind of what it looks like, depending on who you are and what your priorities are. And when it comes to rope access, we consider it, safety-wise, somewhere in the neighborhood of restraint. Because you've got a primary system, which is essentially a suspension system. It's a positioning system. But then you've got a backup system that is kind of fall arrest, but it doesn't allow that 6-foot fall. It only allows a maximum of a 2-foot fall. So it's somewhere kind of in that, as far as safety is concerned, it's kind of in the neighborhood of restraint. Unfortunately, in terms of training, it's a little higher than that. So you've got to have the higher skilled guys and a little bit more investment in your time and your training and your techniques and your equipment. So your investment is a little higher. Whereas with a restraint, you put a leash on a guy, that's pretty simple. There's not a whole lot of training involved in that. Just don't unclip. With rope access, there's a lot more training. So rope access is a dual rope system. What do I mean by a dual rope system? Well, by a dual rope system, I mean that each man is on 2 ropes. And you saw that in some of the other pictures, and actually I'll just show another one here. Each man is on 2 ropes. There's a primary rope that he's using for ascent and descent, and there's a backup rope that he's using for backup. And you can see he's got a little backup device right there. And it's on a very short lanyard, and if he falls, he can take up to a 2-foot fall. Okay, that's not a big old whipper, it's a short fall. And he takes it on a sternal attachment. Yes, sir?
Is the safety rope, attached to a rope grab kind of a device?
Yes, the safety device, this thing right there is actually a rope grab. It's actually it's kind of like a fall arrestor, but the rope access ones are designed to be capable of a 2-person load because we do buddy rescue as standard practice. And so, and they also have to be designed to be able to be taken off and put on rope very quickly and easily, because if I'm doing a rope-to-rope transfer, which I'm going to show you here in a minute, I need to be able to do it without having 6 hands. So and then this piece right here, that's just a positioning device. That's just something to keep him close to the bridge that he's on. Both systems are interchangeable. His primary can become his backup. At any given moment, he can do a changeover to where he's on his primary, he changes his primary line to his backup line and vice versa. Always maintaining 100% fall protection, always maintaining 2 points of contact, a point of contact on his primary line and a point of contact on his secondary line, which means that sometimes there's 2 points of contact on his primary line and 2 points of contact on his secondary line, because as he removes them and takes them on and off for a moment, there's 2 there. Rope access also permits ascending, descending, and horizontal movement. That horizontal movement one is a little bit difficult to understand, but I'm going to try and show you that here in a second. It accommodates self-rescue. The fact that we're sternally attached, it allows us a lot more versatility. We're closer to our system. We're able to look and rig and see what our equipment is doing at any given time. We're able to change over from ascent to descent very, very easily, and that's essential for that frontal attachment. And then it also accommodates partner rescue. We're trained as rope access technicians. Anything that you can do, you've got to be able to rescue somebody else from as well. And on any given site, anything that somebody can get themselves into, there's got to be somebody on site that can rescue them from it as well. The advantages of rope access are many, but obviously safety and exposure is big. Cost and time savings are also big. And the important thing to realize here is that when you switch over to a rope access program, you're not switching. You're not throwing away your standard, your typical fall protection methods. You're using them in conjunction. You're using the right tool at the right time for the right purpose. This is just an interesting fall incident rate comparison. Fatal falls rate per 100,000 workers in the United States in 2013 was 3.3. That's been pretty consistent. I don't have any data from rope access since 2008. That's the last time this big study was done. The thing in the UK is they have a SIC code for rope access. It's specific to rope access. We don't have one of those. So we can't pull our data out of, in the United States, we can't separate our rope access data from other types of data. But in the UK, they can do this. And what they saw in the UK is that their rope access incidents were a rate of 1.3 in 2008. And if you averaged it over 1989 to 2008, because early in the years of rope access, there were still some people using weird equipment, and they had a higher rate. But even then, their higher rate was lower than our rate was in that year. And their rates are actually a little higher than ours as far as their overall fall protection rates. So according to that study, the things that kept fall protection at the bottom of the list as far as things you want to do, the top of the list as far as things that kill people, making protection more feasible, promoting proper use of equipment, and facilitating rescue is actually going to save lives. So let me show you the systems. The sternal attachment, and in this case you can see that this young lady is ascending. She has a chest ascender right here and a handled ascender here. Those two ascenders together make an ascending system. So she's able to ascend up the rope. She has, you can't see it, it's over her shoulder just behind her head there, but she has a backup system on as well. She has that rope grab type device that she's trailing along with her as she goes. When she comes down, she'll switch that into a descent mode. She'll put a different device where that chest ascender is, and then she'll move the ascenders and go down. The idea behind rope access is not to allow that 6-foot fall to occur. That 6-foot fall that's allowable in fall arrest is not permissible in rope access.
Do you by chance have a dissection or a kind of a design of how we set up this ascender device? Show a picture?
I think that's probably the closest that I have. I don't really have much of a diagram. There might be one a little bit later here. Yes. Oh, did somebody say something? But if you go online and Google rope access. There are a lot of different systems there, but I would encourage you to actually put one of your guys in a class, or go take a class yourself and go watch the class, or even just go watch a class, because it's very enlightening. The Subpart D, when OSHA was rewriting the Subpart D, they actually came and took a class, because it's so different from what we imagine. We imagine it as climbing and caving and rescue, and it's not. An example of rope access work done, you know where this is, right? The Seattle Space Needle. It had never been cleaned or maintained on the outside in its entire history. So about 3 or 4 years ago, they cleaned and pressure washed the entire thing. It took 5 technicians, 7 weeks working at night. And prior to that time, it couldn't be done. It physically couldn't be done. What are you going to do, put a scaffold up there? So this is an example of where rope access makes protection more feasible. This is a place where rope access is used a lot. Some people say that there should be height limits on rope access of 300 feet. There's absolutely no logic for that. It really doesn't matter how high you are. There are concerns with, if it's too windy, well, wind turbines usually are in really windy places, and rope access is one of the most common ways that work is done on turbines, because it's way more versatile and you can access all the nooks and crannies and complicated pieces. 2 workers can do 6 to 9 blades a day. That's 2 to 3 times what you can do with a truck. So much more efficient and safer. Yeah, a lot of people use lifts. They'll use lift trucks to do it, and there's limitations getting them in. But how else are you going to do it, right? It's like there's not a lot of options on a lot of those sites.
So when they design those wind turbines, do they put anchor points, especially for rope access work?
That's a little bit of an awkward one, but the biggest problem with anchor points on wind turbines is the European regulations for fall protection are different from the US regulations for fall protection. So there are a few fall protection points, but they don't meet US standards most of the time. But even when they do, they're often in the wrong place. It's like any work environment. And a lot of people think that the lifting points that they use to raise the nacelle into place are anchor points. They are not. Don't tie off to those. Those are not intended as anchor points. So you really have to be creative on some of those turbines. You can also do the inside of a turbine. There's ladders on the inside of the turbine, but you can only reach what you can reach from the ladder. So you can reach other parts of the interior of the turbine tubes with rope access as well. So this is what I mean about moving horizontally. If I hang 2 sets of ropes, I can actually move from one set of ropes to another set of ropes to another set of ropes to another set of ropes, and move all the way across a structure. Sometimes people will go all the way, they'll move over a set of ropes and they'll work their way up on an inspection. A lot of engineers use it for inspection, bridge inspections, for example. So they'll move over, work their way up, and they'll move over and work their way down another set of ropes. And then while they're doing that, another couple of guys are re-rigging the first set of the ropes over to the next point. So they work their way down, and then they do a switch over and they work their way up. And it's much more efficient, and you don't have trucks blocking the highway. And again, at any given time, these guys are attached to at least 2 sets of ropes, or at least 2 ropes, and at times they're attached to 4 ropes. So at all times, they've got at least 1 set, primary and backup, and sometimes they have 2 sets, primary and backup, primary and backup. This is an example of the Bureau of Reclamation. Anybody in here from Reclamation? We've got a great rope access program in reclamation. They were some of the pioneers in the industry in the United States, because some of those places are really difficult to get to. You just can't get there from there. And these guys are doing, this guy here is doing a re-anchor. So actually, I don't know, can't tell for sure actually whether he's doing a re-anchor or if he's just doing a deviation. But he's got the ropes rigged to prevent swing fall and to position himself so that he can actually go down a different line. And there are ways, as you rig this, there are ways to move through that system so that regardless of which side of that system you're on, you lower yourself out on a lowering system so that you're never in swing hazard. And it's all a matter of learned technique. This is something called a horizontal traverse. This horizontal traverse is being performed near the Grand Canyon at a place called the Skywalk. Anybody ever been on the Skywalk? Pretty cool. The problem with the Skywalk is that they built a really neat window cleaning system to work underneath the Skywalk so you could clean, and it worked for the first year. And then it was going to be like $1 bajillion to fix it, and they didn't have the resources to fix it. And they said, well, what are we going to do? We can't have people walking on dirty windows and looking through dirty windows. So they got the job done with rope access, and these guys actually use what we call a horizontal traverse system, and again, always attached to at least 2 points, and in this case, sometimes 3 points, as they move through the system to set their anchors moving forward. And that's what it looks like. And he can move all the way around the structure. So he starts up here where you can actually get on ground. At the point where I'm standing here, you can actually just reach up and clip in. And so he starts there and just works his way all the way around. And somebody does the same thing on this outer tube here. And then they build a little system for somebody to stand inside and clean these windows. And that, from the top, looks a little like that. So you can see he's got multiple ropes rigged so that he's basically suspended sideways inside the tube, or inside it's not even a tube really, but in between the two walls there. Now, if we were using a system that you could only clip one way and had to clip always to this thing, it'd be a little harder to do that. The guys wouldn't have the versatility to be able to say, to make a judgment call. These guys are all deemed competent people. They've been given guidance by their qualified persons to be able to say, this kind of thing is okay to attach to this. So every site still needs an evaluation. It still needs an analysis done by a qualified person. And the guidance and guidelines are given to the competent person to say, this is okay, this thing's not, this kind of thing's okay, this thing's not. And the more experienced guys become, by the time they become a level 3, they usually kind of know almost enough to be a qualified person themselves. Again, this is I was saying this is about as close as I have to the way that they're attached to the rope right there. But there are two things on ascent mode. There's a handle descender and a chest ascender, so that when you slide one up and then you stand up in it, the chest ascender moves up with you as you go. Not strictly rope access, but we also do something called lead climbing. Lead climbing is kind of climbing beyond your protection. This is not true rope access, but we do teach it to rope access guys because there are times that you just can't protect a site. There's just no way. Somebody's got to be first man up to put an anchor in. And so we use typical fall or rest philosophy there and say, okay, it's okay to take up to a 6-foot fall. And when you take up to that 6-foot fall, your force needs to be mitigated to the 900 pounds. So that's the only place that rope access really accepts fall or rest philosophy. So I don't know if that picture is any better either. But again, it's the whole interchangeability that is really the key. And through rope access, obviously you can reach locations that are otherwise pretty much unreachable, and you can definitely do it above 300 feet. That little dot right there is that little guy right there. And there's another guy up there, it looks like, on that one. So the ability to reach difficult locations and access things that otherwise are unreachable is really important. The ability to do projects in a timely and safe fashion is also very important. The typical way this project had previously been done prior to them starting to use rope access was using conventional methods, and it used to take 2 technicians 8 days, and actually they would often have 3 to 4 guys on the site during certain parts of the day to do the work, and they got that down to 2 technicians in 2 days using rope access techniques. Rope access can be combined with other conventional methods, as I said before. Anybody been on that bridge? Before it opened, it had to be inspected. And so RopeWorks was commissioned to provide rope access for the inspection. Sometimes rope access companies will work with engineering companies. Sometimes engineering companies will simply have a rope access team on their engineering company. And so it depends on your company and how you do things. This was a joint operation where the engineering company was not the same as the rope access company, but they worked together. And they used snooper trucks, actually, in conjunction with the rope access methods. And they inspected every inch of that bridge in 2 weeks. And then, obviously, you can do the same thing inside of a confined space as well. Again, the methods and the equipment, this one's in Australia, but the methods and equipment that are used are versatile enough to be able to rig things where nothing else can be rigged. A place where you can't put any anchors, well, if your guys know the principles behind what's required of an anchor, then they can build a system that accommodates that need. Rope access is good where you have extreme height. Where it's really windy, rope access is awesome. In fact, I would much rather be using rope access in a windy environment rather than standing on a giant wing, which is essentially what a powered platform is, right? When there's lousy ground where you can go down but you can't come up, that's a great place for rope access, or where you can go up but you can't go all the way up. You have to come back down. Those are both great places for rope access because they can go both directions. And where sensitive things are involved, where there are things that you need to be able to touch but you can't really walk where you need to walk to get to them, rope access is an excellent choice for that as well. The frontal attachment point, I can't express enough how important that is. Our European friends have long accepted the frontal attachment point even for fall arrest. We don't do that here in the United States, but for limited fall arrest, we do. We have begun. And I think there's an important consideration there because what I can't see, I can't manage. I do want to briefly mention powered devices for rope access, and some of you may have picked up on the fact that some of those photos that I showed earlier, people were actually on these powered devices. And I want to point out that these powered devices are not simply single-point suspended scaffolds. These are powered devices designed for rope access. This is a powered ascender, and it has a descent capability built into it as well. So instead of using those frontal attachment point things that I showed you, the handle descender and the chest descender, instead you clip into this puppy and it raises and it becomes your ascender and your descender, and it speeds things up dramatically. They're being used a lot on bridges right now because they speed up the job quite a bit. Way lower physical exertion. Training's pretty easy on them, but we do recommend that people that use them, we don't make this product. This particular product's made by Harkin, but we do recommend that where people use it, that they are trained and certified in rope access. So just because it's a powered device doesn't take away the need for rope access training, for that capability to be able to do self-rescue, partner rescues, changeovers. In fact, it makes it just a little bit more difficult. So it's a good idea to be certified. You can, absolutely. Yeah, it will take a 2-person load. There's an example of what I was talking about earlier, how it becomes your ascender and your descender. So that's the young lady that was ascending, and this guy is ascending too, and they can both switch. When she switches over to descent mode, she's going to have to put some different gear on the rope. When he switches over to descent mode, he doesn't have to do that. You can also sit on it. So that is another way to use the device. And they are, as I say, they are quite different from a single point suspended scaffold, not the same thing. They are, most of them, rated for rescue, but check the ratings on them to make sure that they're rated for rescue, because not all of them will take a full rescue load. So you can see that attachment point there. I would encourage you, any of you who use fall protection, I beg of you to please put every one of your guys in a dorsal attachment point and suspend them and make them self-rescue. Teach them how to self-rescue. because I actually have a book out there on this, as Sandra mentioned, and it's a topic that's near and dear to my heart because we have lost people hanging there waiting for rescue, and there's absolutely no excuse for that. I've worked with Alpine Rescue for a number of years, for 30 years actually, and I'm a strong believer that if you can get yourself into a predicament, you need to be able to get yourself out of it. I have been, in the course of my life, in a couple of different fire departments. I have been 911, and I can tell you that 911 is not always prepared for your environment. They don't always know even what you're doing. So as the employer, you're responsible to be prepared for rescue and be able to get somebody out of a problem, even just a simple fall, within 15 minutes. But that's another presentation. For rope access, you need competent technicians, appropriate equipment, and proper management. That's really all you need for rope access. And there's lots of organizations and people out there that'll teach you how to do it. SPRAT is a great place to start, Society of Professional Rope Access Technicians. It's a nonprofit organization that's just dedicated to keeping people safe. Technician competency includes certification by an appropriate third-party entity. Doesn't really matter if they're SPRAT or IRATA or FESAT or ARAA, that matters not a whit, as long as they're using the international ISO standard for rope access. That needs to be the foundation of what they're doing. Simple techniques at a base level and advanced techniques later, but no matter what you can do, you got to be able to rescue somebody from it as well. By equipment, I mean equipment that you can ascend and descend with. It's always, always, always got to be a two-rope system. The redundancy, meaning the failure of any single point will not cause catastrophic failure. So redundancy is very important. And duality is important. Duality meaning the primary line and the backup line are interchangeable. Don't use a descender and an old-fashioned fall arrestor for your second line, because there's no duality in that. And that limits you then in terms of your capability to do self-rescue as well as partner rescue, and it also limits your capability to get yourself out of trouble if you need to do that. Rope access equipment, stuff that's designed specifically for rope access, will accommodate a two-person load so that you can do rescue. That means your descenders have to be capable of a two-person load. Your backup devices need to be capable of that two-person load. You've got to mitigate that fall potential. Don't accept the 6-foot fall, 1,800-pound force philosophy from the old fall protection or the old fall arrest world. Those numbers are no good for rope access. And of course, you have to have periodic inspection of that equipment. As far as management is concerned, a rope access plan is imperative. The rope access plan can really just be a subpart of your comprehensive managed fall protection plan. And just plug a book I'm writing. I've just put to bed a book on rope access and on managing rope access in the workplace. It's published by Wiley, and it'll be out in a couple of months. And it's designed to do this. It's designed to walk you as a manager through how to manage a rope access program and integrate it with your comprehensive managed fall protection plan. Your supervision needs to be by people who know rope access, not by just everybody, but teach your people rope access before you expect them to supervise it. I'm starting to see that with employers bringing rope access teams in to do rope access work, and their safety supervisors have never seen rope access before. It's not fair. It's not realistic. It's not nice. Train those guys in rope access before you make them supervise it. Duties obviously should be commensurate with experience. Rope access should be managed in a way that allows it to interface with other fall protection methods. When you're doing rope access, that doesn't excuse you from following fall arrest and positioning and restraint rules when those rules apply and when you're doing those types of protection. They're all just different tools in your toolbox. And of course, record keeping is incredibly important. As an employer, the employer has to approve the method. Is it okay to use rope access or is it not? If so, who can use it and how? Overseeing the rope access plan, making sure it's properly supervised, making sure the rigging methods are something that you as a company agree with. Again, those duties being commensurate with experience and all the record keeping and planning modes as well. To become a technician typically takes 5 days initial training for a level 1. That basically qualifies a guy to work under somebody else's supervision, under the supervision of a more supervised or a more experienced technician. The certification is rigorous. It's not a walk in the park. I'm getting to the point in my life where I'm not even quite sure I'm going to recertify every time it comes up. I think I'm due this year and I'm going to do this year, but I'm kind of getting to that point where, maybe I'm not going to do this anymore, because it does get hard. As I sit behind a desk more and more and spend less time in the field, it gets harder to do. Third-party evaluation process is very important. I shouldn't be able to train you and then certify you, because I've got a dog in the hunt as to whether or not you pass. So SPRAT feels very strongly about that third-party evaluation process, and that's for the safety of you, the employer, as well as the safety of the technician. The fall incident rate comparison that we talked about before. Rope access can be used and is used in just about every environment, every industry. Is anybody in here actually using a rope access or have a rope access plan in your place at this point? Okay, so a few of you. So almost every environment. There's really not a whole lot of places where rope access is inappropriate. It's just a matter of choosing the right skills for the people and the right kinds of people and the right equipment to make it work. It's typically a lot easier to take people, and a lot safer, to take people who are tradesmen and good at what they do and teach them rope access than it is to take a generic rope access technician who learned to be a rope access technician so he could paint and try and turn him into an NDT inspector or something. It's a lot better to train people who have trades and skills in rope access than the other way around. Anybody recognize that building? So rope access has indeed been done on that building. And in fact, if you can't see them there, there's people right there. And if you can't see them there they are. So that's work, inspection work on old, ancient buildings, buildings that have a lot of complicated facade, that are historical monuments that they don't want to put scaffolds around. Rope access is definitely a great choice. This is one I just kind of threw in there because it's an example that I used in my book, actually, of just a financial example. Rope access had to be done on this bridge. Actually, they had a problem on this bridge. They had a crow's nest right there, and they really couldn't get to it. You couldn't get a truck down in that gully to get up to it. It was really complicated, so they said, well, how are we going to do this? So let's do a snooper truck, because we know a snooper truck will work. So they scoped out the scooper truck. It's going to be a $22,000 job. This is a highway, so this direction's going this way and this highway's going that way. So they were going to have to reroute from the previous exits. They were going to have to reroute traffic along a several mile stretch. And it was going to there's going to be road crew involved and the snooper truck guys involved, and they weren't sure if the strength was sufficient, and it was just all very complicated. So they said, well, let's look at a rope access project. So a friend of mine bid on this job, and they ended up doing it for $2,500 with no road closure. The guys were self-sufficient for rescue. A two-man team, that's all it was, no rerouting of traffic. And it took them a half a day to do it. So I am here at the show. I have a company here at the show. PMI is here at the show. We do have a booth there. We're in booth 1218. So I would encourage you to stop by and see us. We actually have a power seat in the booth if you'd like to see the power seat. And here's contact information for the company, and then also contact information for the Society of Professional Rope Access Technicians. As I said, it's a nonprofit organization. They're very focused on safety, very focused on just making sure that employers and employees have the resources they need to keep people safe at height. That's really kind of all it's all about. So if you have any questions, I'll be happy to take those at this time. Yes, sir.
So do you think when ANSI finally gives that standard out that it's going to make everyone who uses, well, Petzl gear, for example.
Yep.
So handle centers aren't ANSI rated.
Right.
So do you think that's going to kick TESOL out?
No, absolutely not, because you can only ANSI certify anything that has a test. Right now, there's no test. And this is actually, I'm glad you asked this question, because it's a matter of great confusion. People ask for ANSI certification on everything. There's not an ANSI certification for all products. There just isn't. And so it's up to you as the employer to make sure that a product is safe for its application. OSHA, who sets regulation, says, here's what your system has to be capable of doing. Now, Mr. Employer, it's up to you to make sure that that happens. So as an employer, what do? We look at the ANSI standard, because that's the easy way of making sure that the system meets the OSHA regulation. But OSHA does not say you have to use ANSI rated equipment. OSHA says your system has to be safe, and it has to have these key, 5,000 pound anchor, yada, yada, yada. And so it has to have these key components. ANSI is simply, the Z359 is simply a way to achieve that goal. There are other ways to achieve that goal. And you can and should use other ways to achieve that goal when it applies. Now that said, OSHA is rewriting Subpart D, and so those rules are going to change, and I have no idea what they're going to say. Also, ANSI Z359 is in the process of writing a rope access chapter. It's called Z359.8. I don't know that it'll ever be published. We've been working on it for 10 years. I have no idea if it's ever going to come out or not, because the mindset of fall protection in the United States doesn't understand this stuff. It's really been hard for us to wrap our heads around. So will that ever come out? I don't know. But if it does, there will be a test method for handled ascenders in the United States for rope access, because we've written it already. So whatever you use, I would encourage you to research what it needs, what the performance requirements, what you need the performance requirements to do. And all good manufacturers have done some testing on their products, and most of them meet some standard, whether it's an NFPA standard or a European EN standard. Most of them have some sort of a certification on them, and so you can find out what that performance is.
The program, the 5 days program, does it include any physical or medical screening of the workers who comes?
No, it does not. The question is, does the 5-day training, does it include any physical or medical screening? No, as you come into the course, just as you come into a fall protection training, you simply have to have a waiver that says, you have to sign a waiver that says, I'm free of anything that's going to...
So it's the owner's responsibility to make sure that people are physically fit to work in those situations.
Yes, absolutely. And actually, ultimately, it's the worker's responsibility to determine that, yeah, I'm okay to do this kind of job.
Yeah, I ask this question because I work in a different region, and the rules and the controls are a little different than in
Sure.
States.
Yeah, that's fair. Are there any other questions or comments? Sir. That's the name of it. Falls at Height, or Falls from Height, A Guide to Rescue Planning. It's published by Wiley. It's available through the ASSE store, actually. They sell it through the store here. I don't know if they have any copies here. They don't bring very much stuff to this show usually. It's also sold, obviously, at my company at pmirope.com, but you can get it off of Amazon as well. And you can download it, or you can buy it hard copy. The rope access book, as I said, I'm literally like on the airplane here. I was editing chapters, so I'm in the just putting it to bed right now, and it should be published by September. And again, the goal is really to give employers a resource, and it's got a lot in it about techniques and equipment selection, and it's got a lot of breadth in it, but it also has a lot of regulatory and management stuff in it. In fact, it's largely focused on that, because that's the hard part. I mean, the skills, yeah, anybody can learn the skills. The hard part is the details, is knowing, what do I do with these guys? Where do they fit in my system? So, thank you guys very much for being here today. I really, really appreciate it. If you'd like to chat, I'll be around a little while longer.